will you ever like win an argument, like say like they say brand box, but they don't say it's like identical, and that's kind of ambiguous?
Kind of ambiguous. So if you said, I'm unsure in this question, you could ask for clarity, and if it's something on the exam that I can say and clear it up, I could. If not, I would just write on the exam, I'm assuming the 5 brand boxes are the same. Right? Now, if they had 7 people on the shelf, 5 of them were named Brett. One was Graham, and the other one was Puffy, right? Then I don't think you could assume all 5 Bretts were the same person. Then it'd be 7 factorial. That would be a really mean question to ask, because it's just designed to like confuse. But you can just say, I'm assuming the 5 brand boxes are the same, and then work with it from there. And then you could have an argument to say that you should get full marks.
Do you know what's on the exam already? Like, have you seen it?
No, I don't get to see it until the day you get to see it.
Really?
Yeah. Although I know that there's going to be trait logarithms are going to be on there.
You're not on any teacher group chats like Miss B is?
Oh my god.
No, I don't have them.
What was the first question? What was the circle?
4, 5, 6, and 7.
No, wait, the last one? Number 1? Number 1 was 3, 4, 5, 6.
Oh, 3, 4, 5, 6. Sorry, I got confused. 3, 4, 5, 6. There you go. Yes.
Okay, I'm sorry I'm asking questions about the exam, but do they like favor certain units over
Yes.
other ones?
Yes.
Which ones do they favor?
The trigonometry ones.
Oh,
Those are the biggest.
oh. Wait, so there's
Trigonometry is 2 out of your 8 units, which is about what? 2 out of 8 units is 25%. No, maybe not favorite.
so
Say-
they're more like
25% of your exam.
so it's not like likely
They're all about like basically how we've done the course. The bigger units, more exponents and logs than you would get of the polynomials unit. A shorter unit. Okay, Graham walks 8 blocks from his home to the library. He walks 4 blocks east and 4 blocks south. So I'm going to draw a picture of this. There's. He walks east and south. So his home is here, the library is down there. There we go. There's his home. There's the library. Now we are assuming Graham has some sense of direction. Okay? Like he is not going to let me just get this all grouped together. And I also want to lock it in place. There we go. We're gonna assume that Graham doesn't do this. Oh, where's the library? I want to. Where? Whoa! There it is. That's not how Graham. We're gonna assume Graham always is going to be getting closer to the library. So this isn't one of the paths. However, he could do this. Right? He could do this. He could go do that. Or do this. Or do this. How many am I? Is someone counting as I'm doing these? We want to make sure we count them all. Oh, I know I haven't counted that one yet. That one. How many am I at?
22.
22? How many more? Did I get them all? No. This is not a good method, right? Do you see yourself getting lost in what you've counted along the way? But if we consider he walks 4 blocks, I think this is the easiest way to get it. How can I represent this? He would have to go east, east, south, 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 east, east. Easy. Perfect. That is an easy way to get there. Now that's one way. Can you see this is an identical objects question? Because each path that's different is going to rearrange those letters. He has to go south 4 times. He has to go east 4 times. If they were different letters, it would be 8 factorial, but we have to divide by 4 factorial for the e's and 4 factorial for the s's. And I saw it earlier, the final answer is 70. You could also do this systematically, and a really cool pattern happens. Okay? Now, if the library was here, can you see that there would be only one pathway that he could get there? In fact, if the library was at any of these dots, like if the library was there, how many different routes can he take? Only one. In fact, all of those would be one. All of these ones, straight down, would be one. How many ways can he get to that dot? How many paths are there to that dot? 2. How about this dot, which is going to be the same as this dot? 1, 2, 3. Where's the 4th one?
Down.
Yeah, I counted this one. Down and over 1. Over, down 2. 3. Any other ones?
You can go down, right, up.
I know, and then he can't go back up.
You can't go back up.
Because we're assuming Graham is smart and is always getting closer.
What about diagonal?
No, there's like cocaine hippos in between or something.
Okay.
So 3 for here, 3 for here. And there's a pattern here. I'm going to give you the next 3 dots, and you're going to see if you can figure out the next ones. This one is 4. This one is 4. This one is 6. So now, let's see if we can figure out these blue dots here. Look for patterns. What do you think the bottom one's going to be?
5.
5. Did you use the pattern 1, 2, 3, 4, 5?
Yeah.
Nice. 1, 2, 3, 4, 5. These ones. There's another pattern that will help you figure out those ones. Check out the 6. See if you can figure out a way to get the 6. It's not 8.
24.
No, it's not 24.
16.
And here's the strategy to figure it out. So if I look at the 6, how do I get to this dot? I either have to come from here, right, to get to that dot, or I have to come from here. And if this previous dot, there was 3 ways to get there, and 3 ways to get there.
Is it 12?
No, it won't be 12. 3 ways to get here, and 3 ways to get there, making 6 ways in total to get there. So to get to this blue dot, I can either get there from here or from there. If there's 6 ways to get there and 4 ways to get here, there's 10 ways to get to those dots. And that makes this one 15. And this one 20. And this one 15. And this one 35 and 35 and 35 and 35 gives me 70, just as like before. So 2 ways you can do this question. You can do it as an identical objects, or you can systematically count it. The identical objects works when it's nice and simple. You will sometimes get questions like this where they put like a pool or a lagoon in the middle
Hippopotamuses.
where the hippopotamuses live. Exactly. And then we have to rearrange our thinking. And have to count it this way because then the letters don't work. But we don't have a pool of hippopotamuses in this. Okay, questions to circle for this one. Number 12.